All right, so we learned how to divide polynomials by long division last time, which works in every situation when we're dividing polynomials, but it is a process that's got a lot of spaces for error in it, and it does take up a lot of space. So we're going to learn about another process to divide polynomials today called synthetic division, which is a lot shorter and a lot easier, but doesn't work in every situation. So first of all, we need to know when synthetic division works. Synthetic division only works when the divisor, the thing on the bottom, is a first-degree binomial with an x coefficient of 1. So what that means is, like in this problem that I have here, the divisor, the thing on the bottom, the power on the x can't be bigger than 1, and its coefficient, the number in front of it, can't be bigger than 1. If either of those things are true, synthetic division can't apply, or things would have to be adjusted before you can use it. All right. So on these first two problems, synthetic division will apply. So what I'm going to do is I'm going to pause the video really quickly and do this first problem by long division so we can have it like in front of us. So when we do synthetic division, we can sort of see what's going to be happening. There we go. If only all long division problems went that quickly. So there's the answer that we would get if we did this by long division. So now I want to show you how to set up a synthetic division problem and how to execute it. So synthetic division problems will never take up any more than 3 lines on your notebook paper. So I'm going to go ahead and draw some notebook paper lines. You don't need to draw these. These are like lines on your notebook paper. And on your notebook paper, the first line, you're going to have a little box here. And then in between your second and third lines, you're going to draw a line like this. Now, the way that Alex sets it up looks a little different than this, but that's okay. You can adjust it either way. I'll be able to read it. Now, in the little box that goes here, you're going to put a number that represents your divisor, the bottom of your fraction. And the number that goes there is the number that makes your divisor equal to 0. So in this problem that I'm doing, I would set x plus 2 equal to 0 and solve that. That gives me negative 2. That's the number that goes in this box. And then along the top line, on the other side of that box, go the coefficients of my dividend. Meaning the coefficient of the top of my fraction. So that's 1x to the 4th, 3x to the 3rd, minus 5x squared, 4x, and negative 6. Notice we don't have any like x's or powers there, just the numbers. And then as the final setup step, that first coefficient of my dividend, the 1, I'm going to bring it down below the line. And I'm going to draw an arrow to indicate that I've done that. Now, I am ready to do the synthetic division algorithm. So the algorithm, unlike long division, which is 4 steps, divide, multiply, subtract, bring down, synthetic division is only 2. It's multiply and add. So the first step is multiply. You take the number that's in the block box and you multiply that by the last number below the line. So negative 2 times 1. And that goes in the next column above the line. And then you take the 2 numbers that are stacked on top of each other and you add those. So 3 plus negative 2 is 1, and that goes below the line. And then you simply repeat that process. Negative 2 times 1 is negative 2, and you add those, and you get negative 7. Negative 2 times negative 7 is 14. 14 plus 4 is 18. Negative 2 times 18 is negative 36. Negative 6 and 6, 36 make negative 42. Once you get to the end, you take that number and you box that off. Now I want you to look at the numbers that we got here at the end. This 1, 1, negative 7, 18, 1, 1, negative 7, 18. Pretty cool, huh? And then this negative 42 that we got at the end, negative 42, that's the remainder. This is the answer to my division problem, and it's all laid out right here below. So basically, when you get done with your synthetic division problem, your quotient is the stuff below the line. You have the coefficients there. And the way it works is this first coefficient, because we were dividing by something that was like to the first power, it's 1 x, and then it's going to be raised to the power that's 1 less than what we started with my dividend. So it's going to be 1x to the third, because we were dividing by something that was x to the first. So then it would be plus 1, and it goes down by a power. Minus 7, down by a power. Plus 18, down by a power, so there's no x there. And then my remainder. And of course, you could write that as minus 42 over x plus 2. And that's my quotient. Now, because there's no x's or like x cubes or keeping up with any variables in synthetic division, it's really important if you're missing any terms that you put placeholders in. So if I'm doing this problem, notice I'm missing an x cubed term. So when I go to set up my problem here, I'd start by setting x plus 3 equal to 0. That goes in my little divisor box. I'm going to go to put my dividend coefficients on the line next to that. 1x to the 4th. I'm missing an x cubed term, so I have to put a 0 in. That's really important. And then 3x squares minus 5x's and plus 2. Bring my 1 down, and then multiply, add. Multiply, add. Multiply, add. Multiply, oops. Add. Box it off. My coefficients of my quotient are there. It's 1, and then you start with a power 1 less than what you had in your dividend, and go down from there. And the 125 is my remainder. Now, when the coefficient is not 1, we can actually adjust the problem and still use synthetic division. So let me show you how that works. So when I'm looking at this problem, notice I'm missing a constant term here, so I'm going to put a 0 in on the end. I can factor a 3 out of that thing on the bottom, and that would leave me with 1/3 there. And so what I'm going to do with the synthetic division is go ahead and divide by x plus 1/3, and then at the end I'm going to divide all the stuff, the quotient, by 3. So watch this. I'm going to set that divisor equal to 0. I'm going to write all my coefficients. I wrote 3x to the x. Just realized that. I'm going to bring my first term down. Negative 1/3 times 3, and then add those. Negative 1/3 times negative 6, and add those. Negative 1/3 times 3, add those. Negative 1/3 times 6, and add those. This is my remainder. And then I've done the division by x plus 1/3. So now I'm going to take my quotient, and I'm going to divide that by 3. Now, I want to explain why I don't do it to the remainder in just a second. So that would give me 1, and again, I'm going to start with a power that's 1 less. Minus 2 plus 1 plus 2. And then my remainder, negative 2, is already going to be going over my original divisor, so it's still being divided by the 3 and the x plus 1/3, so I don't need to divide it by the 3 at the end, because it's still going to be over that 3. So pause the video and try that next example, and then unpause it and see if you got it right. All right, there's the answer you should have gotten. Check your answer, make any corrections you need to. All right, now, just as a preview of where we're going with this, whenever you're talking about arithmetic, if you talk about a number being a factor of another number, it goes into it evenly. So for example, 4 is a factor of 24 because 4 divides into 24 without a remainder. So same thing is true for polynomials. So if I want to find out if x minus 5, for example, is a factor of this, I can find that out by dividing it into this and seeing if I have any remainder. Now I could do that with long division, but again, long division is kind of a process that's got a lot of room for error. Synthetic division, though, would be easier. So if I divide x minus 5 into this thing, and I get a remainder of 0, then that means yes, x minus 5 is a factor of this because it went into it evenly. So that means x minus 5 times 2x squared plus 7x plus 3 gives me this original polynomial that I had. So if I wanted the other factors, I could take this quadratic and factor it using the methods I already know. So I've got x minus 5, and then this thing would factor into 2x plus 1 and x plus 3. So would you go ahead and try to pause the video, try the problem at the bottom, and then unpause it and see if you got it right. Here's what you should have gotten. So keep in mind, again, that because I had a coefficient on that 2, I have to take my quotient here and divide it by that 2, which is why this is 3x squared minus 8x minus 3 and not 6, negative 16, and negative 6. All right, you are now ready to practice this using the synthetic division maze.